So, welcome to part 3 of chapter 2. So, let us try to understand the experiment given our page number 22, figure 2.3. So, here, this setup here, let's say this here is a battery. So, in our diagram, the batteries are drawn like this, one long and one short. The long one is considered the positive, the short one is considered the negative. So, here you can see it's something like this. Short and long short, meaning there are three batteries connected here: positive, negative, positive, negative, positive, negative. Okay, so here this is the first battery, this is the second half, and this is the last half. So let us say here its battery is 1.5 volt. Then if you connect 3, it will be 1.5, it will be 4.5 volt in total. So this is how we generally do the batteries, okay, which we are going to see in chapter 12. Here, this diagram, this is how a bulb is drawn generally. Okay, whenever you see this diagram or this circuit, we will understand it is a bulb. This is the key or switch. If the key is given in this way, that means it is open, that means switch is off. If you put a dot here, meaning the key is on or the switch is on. So here we'll go in details later on, okay, when we get the chapter 12. However, let's understand or just a small idea. Our current flows from plus to minus in this way, okay, outside. However, electrons flows from minus to plus, that means in this way. This will clear afterwards. So for now, just let us understand that minus have lots of electrons and plus have very less electrons. So it will move from higher concentration to lower concentration. That means if this is a battery we have here, suppose this is the plus point here, this side is the minus, this side is the plus, and there's a boundary in between, barrier. Means here lots of electrons will be there, and here almost no electrons. So this minus will try to move here, but there's a boundary in between, so it cannot move this side. So what you do, when you connect a wire maybe from plus to minus, electrons will move from this minus to the plus now. So I hope this is clear. So what I'm saying here is electrons will move from minus to plus, and when electrons move, we call current is moving, which we're going to discuss in chapter 12. Secondly, this wire, let us say this is the wire here, okay, this wire is made up of metal, and metals have electrons, free electrons, which we're going to study later on. Let us say we're talking about sodium atomic number was 11. If you put it 2.8, 2 is to 8 is to 1, that last number 1, this last electron here, what happened, if it is sodium, then it is free to move around from here to there and there to there, so we call it a free electron. And whenever free electrons are present, then only the substance will allow current to pass. So let us imagine that here are 1, 2, 3 and 4 sodium atoms, okay. That means how many free electrons will be present here? There will be 1, 2, 3 and 4 free electrons. They can move around from here to here, they can go back, and this one can go there, so it doesn't matter. Within the metal itself, it is free to move around. And when do we say current is flowing? Current is flowing when electrons move from one point to the other all together. Lots of electrons move in the same direction. Here I'm saying this might move here, this might move back here, and this may go here, this may go. It's random. The movement will be random, always electrons. However, when we put battery, what happens? The electrons are pushed in a single direction, and then we say the electricity or current is flowing. So here we know, okay, let me take the blue color. Lots of electrons are, let us say inside this battery there are 100 electrons, means towards the negative side. These 100 electrons want to move to the positive, so that negative also contains 50 and positive also contains 50, equal concentration. When it becomes same on both sides, no more electrons will flow. However, right now all the 100 are present here on the negative side. This side or the positive side, there are 0 electrons. Okay, I hope you understood it. So when I connect this battery, okay, before connecting, I have got wire here. One part wire begins here and ends here. The second part wire begin here and end here. Let us say this wire has got 10 free electrons which can move, and this part have how many? 10 electrons. Okay, so now what happens when I put these electrons or put the battery, connect it here, then what will happen? This part battery has got how many electrons total? Total 100 electrons right now, full of electrons. So they will try to move here, okay, into this wire. But this wire can order, it has how many? It had already 10. That means its capacity is only 10. So these electrons will try to enter here, but this wire will not allow the electrons to enter. This side, this part of the wire has 10 electrons, meaning the capacity is how much? 10 electrons. And positive side, how many electrons is there right now? 0 electrons. So this 10 will try to go inside here, but this wire total capacity is 10, so this wire will not allow any 10 electrons to flow here also. I hope you got it. Here in a conductor or whichever or the wire, whatever the total electron was before you connect the battery, that will always remain. Got it? So in this case, what happens here? This wire and this wire is not touching each other, but here we have got water here, and pure water does not allow electricity to pass. So you have got the, or such people advise you not to touch water or switchboard with wet hand because you might get electric shock. That is because suppose the normal water which we have is not pure, they have some amount of salt mix. So salt, you remember, when something become acid and base, we call it a salt. Always some amount of salts or minerals are present in water, so they pass electricity. But if it is pure water, it will never allow electricity to pass. Now let us say here it is, let us consider this is a water here, okay, and some HCl is mixed with it. We know when HCl is dissolved in water, it produces H plus Cl minus. Because it produces H plus, we call it what? Acid. So here that means I will have some amount of H plus, maybe let us say 2H plus and 2Cl minus. So here what happened is lots of electrons was present on the negative side. It was trying to push the electrons to the wire, but the wire was not accepting any because the wire had a capacity of 10 electrons, so it will take 10 electrons. Now what happened when H plus came here, out of these 10 electrons, 1 electron will go to the H. Okay, that means how many will remain here? 9. As soon as it goes, now it will allow 1 electron to enter here, so that the total remains 10. That means give from one side, take from one side. If this side nobody is ready to take, for example, when the water is pure, there was no H plus, no Cl minus which could carry the charge. That time no electrons were allowed to enter into the wire. Now because there is somebody who can accept the electron on this end, now it will give the electron to that fellow and exchange one from the negative. I hope you understood it. Next, this H is now H, okay, because it was H plus, it took 1 electron minus, so plus minus it became how much? 0. Now it is got H now, so this H will come here, and this side we know this positive was ready to accept electrons because it did not have any electrons, but this wire was not allowing any electrons to pass because the capacity of the wire was how much? 10. So what we'll do, this wire will pull 1 electron from our H. As soon as it gets it, it becomes 11. But even before it gets to become 11, it will pass 1 back to that positive. As a result, the total will always remain how much? 10. That means it's accepting from this side and giving from this side. So now what we find is electrons are now moving from the minus to the wire, to the wire, to the ions, from the ions back to the wire, and from the wire to the positive. Now the whole circuit or whole setup will allow electricity to pass. Did you get it? And when electricity is passing, now this bulb will light up. Otherwise this bulb was not lighting. So what we can see here is when we put some acid, it will conduct electricity. Why is it conducting electricity? Because acids are releasing something plus and something minus. And what is the something plus? We already know acid will release H plus. So this experiment proves that acid always releases H plus. So I already told you that we had something called as C6H12O6. What was this? Our glucose. Our glucose, suppose here it's pure water, no acid mix, and I mix some amount of glucose inside. Now, will the current pass? No, because glucose cannot become H plus. If there is no H plus, nobody will take the electron in this end. Nobody will be able to give the electron in this end. As a result, this wire had 10, it will maintain at 10. So no new electron will come or no electron will move, and no moving electron means no current. I hope you got it. Same thing happened for salt. I told you that water conduct electricity when salt is dissolved, because salt, for example, our NaCl, when dissolved in water, breaks up into Na plus, Cl minus, CuSO4 breaks up into Cu2 plus, SO4, 2 minus, and so on. So as a result, either salts or acids will conduct electricity, but our some other compounds such as glucose, maybe alcohol, they will not be able to conduct electricity. Why? Because they are not able to release H plus or OH minus ions. So before going to the next part, let us see two things. Okay, something called as our solution. We already got it in class 9. It was solute plus solvent. I already told you how to count it. 1 2 3 4 5 6 letters. 1 2 3 4 5 6 7 letters. That means this was the less amount, like let's say salt. This was a more amount, let's say, or water. That means we are mixing salt in water. So here I already told you a little bit. Our dilute plus concentrated, CONC dot, you can write it. Okay, dilute means it was less amount or less powerful. Concentrated means more. When I say less, what is less? The salt is less, maybe. What is more? Salt is more, maybe. Maybe you have got 1 cup of water, same amount. Let us say you have got 10 ml, 10 ml. Okay, 10 will be too small. Let us say 100 ml, 100 ml of water. Let's say here you're adding 1 spoon of salt. Here you're adding 2 spoon. So I can call, okay, this is less salt, so less concentrated. This is more salt, so more concentrated. Or I can say this is dilute compared to this. Okay, so here, so what we're talking about is our, in this case, when I say acid, dilute acid, meaning what is it? Acid is there plus who is present? Water. So when say concentrated acid, what is the meaning? Acid is present, no doubt, but who else along with it? Water. Because concentrated and dilute, both terms are for solution, and solution means always solute plus solvent, and in our acid our solvent is always our water. So in this case, what we can see is, you can check all the experiment given, all the examples given, everywhere the word dilute. For example, dilute HCl, dilute HCl meaning less HCl and more water. Dilute H2SO4 means less H2SO4, sorry, H2SO4, but more water. Okay, here for the first time we're going to see our concentrated, means it is not strong. You keep this in mind. Sorry, it is concentrated. Yes, concentrated H2SO4. Keep one thing in mind. Dilute acids are not very reactive, but concentrated are very strong. They can react with almost every metal. For example, they can react with copper also, because they're very strong. It's like this. So let us see the experiment given here. Here it's given, if you take H2SO4 plus NaCl, what will you get? Okay, here it's a salt plus acid. Here H is happy with SO4, Na is happy with Cl. Okay, H wants to take the Cl away, it wants to double displacement. Okay, this reaction wants to undergo double displacement. That means H wants to take Cl and Na should be alone, Na2SO4. Na will have to take SO4, but we know Na is more reactive, chlorine is more reactive. As a result, this reaction cannot take place. However, if I use concentrated H2SO4, it's very strong. That time this reaction will take place to give us this reaction, or we are getting HCl and Na2SO4. So I have understood it. This following reaction will not take place if we are taking it at dilute H2SO4. We have to take what type of concentrated H2SO4. So you can see this in our figure 2.4, page number 23. Here, if you take a test tube and we'll not put the acid first. You take a test tube, you put some NaCl granules or some salt below, and you put very strong or concentrated H2SO4 from on top. You will notice gas coming up or fumes, okay, smoke type. That fumes will be that HCl gas. This is in the form of gas this time. So here our H2SO4, I already told you, concentrated, meaning what? Very less amount of water is here. That means whatever HCl formed will not dissolve in the water here. Why? Because we're taking already dry NaCl and concentrated H2SO4. Already water is very less, so direct gas will come up. So we can say the HCl gas is dry. Okay. Now what you do? You take a litmus paper and test whether it is really acid or not, because HCl is acidic in nature. And what happened? We remember already, acid should turn litmus paper into red. I hope you got it. Here what we're taking dry salt below, we're putting H2SO4 having very less amount of water, very strong H2SO4. Reaction took place and some gas rose. What is it? Some gas went up. That gas is our HCl gas. We know it already. Now that HCl gas, obviously we know HCl is the first acid we learned, so it will turn the litmus paper red. Yes, however, no, it does not turn the litmus paper red. However, if what you do, same litmus paper, you put little amount of water along with it, okay, and now put it in the gas. This time you will notice that litmus paper will turn red in color. So I hope you are getting it. So my point is that HCl gas or HCl, even though it is an acid, which we are very sure it's an acid, cannot turn the litmus paper red when it is in dry condition, meaning acid will not behave like acid. Why behave? I already told you. Whichever can turn our litmus paper red is acidic in nature. Acidic meaning what? It behaves like an acid. It may be acid or it may behave like an acid. Here HCl gas is not turning it into red, so it's not behaving at all like an acid. So how will it behave like an acid? To behave like an acid, what did it need? It needed some amount of water. So why? Let's see the reason here. When I say HCl, let's look at the electronic configuration. Which atomic number is 1? Chlorine atomic number is how much? 17. So this is H, a single electron. Chlorine 17. So how many will be there? 2. Here it will be 8. And here it will be how many in the outermost? 7. 4, 5, 6, 7. Chlorine, how many, or what's the empty space? 1 empty space in chlorine. Hydrogen, how many empty space? 1 empty space. So here chlorine either give away 7, or what does it do? Take 1. So taking 1 is easier for chlorine. For hydrogen, either give away, give away 1 or take 1. Let us say hydrogen decided to take 1, so it became how? 2 electrons. We'll learn in carbons, hydrogen is very small, it can no way control 2 electrons. Okay, so there's no option that hydrogen can accept electron. Then what to do? We'll give away electron. Now, if the hydrogen gives away the electron, it is left with 0 electrons, no electron at all. And hydrogen is very unhappy. At least it needs 1 electron. So hydrogen cannot give or cannot take. Then, so when HCl breaks up, I have been telling you HCl breaks up to become H plus and Cl minus. How does it become plus? By giving away the electron, because it has got 1 proton, electrons 1. When it gives the electron, it becomes 0. So what will it be? P minus E equal to plus 1. Okay, so it becomes plus by giving electron. But just now I told you hydrogen cannot give electrons. This is the reason it needs water. When HCl is dissolved in water, it gives the electron to chlorine and it doesn't become H plus. What it do? It reacts with a water molecule. As soon as it gives the chlorine electron, it will react with one water molecule and stick to it. Water was actually H2O. One hydrogen stick to it, so now it becomes H3O. Because the whole setup has got one less electron, it will become plus. I hope you understood it. So hydrogen cannot, or sorry, hydrogen, yes, cannot give electron if there is no water available. It will always need water. Without water, H cannot give electron. If H give electrons, as soon as it give the electron to the chlorine, it will react with one water molecule to become H3O plus ion. And this ion we call as hydronium ion. Okay, UM. This is the reason whenever you're writing H plus ions, H plus ion, you never write H plus ions. Always you have to write H plus in bracket AQ ions. Meaning aqueous means what? Water is present. That means you have to write on the definition of acid. What are acid? Those which can release H plus AQ ions in water. Okay, so this is very necessary, very much necessary. So never write H plus alone. H plus can never be alone. H plus will be there when water is present. So either you write H plus AQ or simply you can write H3O plus. Both of them same meaning. H3O plus is after reaction. H plus bracket AQ is that your meaning that water is present. So here what we learned is acids cannot behave as acid. Not only HCl, maybe H2SO4 also, same case. All of these HNO3, our what is it? What was it? Sorry, CH3, COOH, all of those, they will not behave as acid in dry condition. That means maybe they're in the form of gas or powder. It will not behave. For example, if you take our suppose H2SO4 powder, and what you do, you put in your hand, will it get burned? No, because it's powder, dry state, it does not react. However, you start to sweat little bit, little water is present. Now it will react with the water. Now give SO4 minus H plus and behave as acid and start to burn you now. So I hope this part is clear. So then let's go to the next part. So the next part is how can you convert concentrated acid into dilute acid, or how can you convert our strong acids into weak acid. Why is it needed to convert strong into weak? Because strong acids are very dangerous. Okay, very reactive, they'll burn almost anything. So let us say we have a 100 HCl present here, and let us say 500 water present here. So it's very strong right now. Okay, the ratio is very strong, so I want it to become weak. So what will I do? For the 100 HCl, I will add some water. Maybe I'll add 500 more water. So total water become 1000. That means in more water, I'm adding the same amount. So that means here the ratio is 1:5. Here the ratio is 1:10. Obviously smaller ratio, this is bigger value. So that means this was strong, this will definitely become little weak, dilute. That means in order to convert concentrated acid into dilute acid, what we can do, simply add water. Or if you are not clear about this, let us say you made a cup of tea. Okay, by mistake you added 2 spoons of water, sorry, 2 spoons of sugar. It became very sweet. How will you be able to drink it when it's too sweet? What will you do? Add some more water. Yes or no? If you add some more water, will the sweetness go away a little bit? Yes, it will become less strong. So this is the same point. To make something concentrated into dilute, all you need to do is add some more water. If you can add more water, the whole setup will become dilute or less strong. So here we have two options. Let us say I have got a test tube containing acid, very strong acid concentrated, and a test tube containing, let us say, water. I want to mix these two together, test tube A and test tube B, so that what happens, it becomes dilute. Okay, so this is my H2O, this is my HCl. Now one thing to remember here is whenever you mix acid and water, the process is highly exothermic. Exo means, I already told you, out. Okay, X. Thermic means, what was it? Temperature. That means it will give out heat. Give out heat meaning it will become very, very hot. Okay, so in this case you've got two options. You take the water, put it into HCl, they'll mix together, become dilute. Or you have second option, take the HCl, put in the water, or both of them will mix, become dilute. So I'm saying here you can mix acid to water, or you can decide water to acid. I will, or nobody will tell you to do this. Everybody will tell you to put acid into water and not water into acid. Reason is, let us say you're adding water into the HCl. So as a result, this is becoming very hot here. Why? Because I told you whenever we mix acid and water, it becomes very hot. It will become so hot it may start to boil. When it boils, some may spill. Spill means come up like this. And what is the majority here? Acid. Now acid will come and may touch your hand and you may get burnt. Got it? Or if it becomes too hot, glass can crack and break down. By chance it becomes so hot that the glass broke down, what will fall down this side? All the acid will fall down. As a result, your leg may get burnt. So what we do is we'll put the acid to the water, so that if it becomes very hot and start to boil and splash or spread out, what is maximum this side? Water. So will it burn you? No. If the HCl added here, it becomes so hot that the glass broke down this side, then what will fall down here? Water will fall down. Will you get harmed? No. So this is the reason we always put acid to water and never water to acid. So if this part is clear, then we will go to the next part in part 4.